Hello everyone. We are giving short explanation of our code. We have used the CV2 library as our requirement is uh, to use less resources and to do fast computation, and that's why we are using only inbuilt functions of OpenCV. So first of all, our code has two main functions. One is pre-processing and another one is processing. Let me explain the first function, that is a pre-processing function. Here we have first of all we have converted the RGB image to the grayscale image. The purpose of our conversion is that the techniques we are using uh, further works better are focused on intensity values rather than their colors. Second, the processing requires less computation if we are using grayscale. Then, as we have underwater images, we are applying white balancing, and to apply white balancing, we have used this xphoto.create simple wv function from the uh, OpenCV library, and it has created a function wv, and using this object wv, we have applied the white balancing to the image which we already converted to the grayscale. The purpose of the white balancing is that as underwater environments absorb red, orange, and yellow wavelengths more readily, leading to dominance of blue or green waves in captured images. White balancing attempts to correct for this color cast by adjusting the intensity values of different color channels. Then we have used the contrast limited adaptive histogram equalization. For that we have used CV2 dot create CHLE function. Let me explain the parameters of this function. The first one is the clip limit. This parameter controls the extent of the contrast limitation. A higher value reduces noise amplification but might lead to less sharpened images. Then, second one is the tile grid size. It defines the size of the tiles. Here, the image will be divided into uh, tiles with size of 8 cross 8. Then, using this function, we have created an object clay, and using this created object, we have applied it to the our gray balanced image, which is which one is first converted to grayscale and then applied to the white balancing. Then let me explain the second function. This is the main processing function. First, the image will be read using the cv2.im read. Then a Gaussian filter is applied to smoothen the image. Then we have used adaptive thresholding to detect edges. We are not using canny edge detection here. Let me explain the parameters. Blurred, here blurred is the name of the input image. 255 corresponds to the maximum value for output image. CV2.adaptive threshold mean underscore C. This specifies the adaptive thresholding method. Here the mean of the local neighborhood around each pixel is used as the threshold value. Then CV2.thresh underscore binary. This defines the type of thresholding. Here pixels exceeding the threshold are set to 255 means white, and below are set to 0 black, creating a binary image highlighting the edges. And what does these 9 and 2 mean? 9, this is the block size parameter. It defines the size of the neighborhood around each pixel used to calculate the local threshold. Then 2, 2 is a constant parameter. It is subtracted from the mean of the local neighborhood to control the threshold severity. That's why this is an adaptive approach rather than a fixed approach. As the pixel changes, the threshold will be changed and correspondingly edges will be detected. Now, next, we have used the contours to find our region of interest. First, let me explain the parameters used in this cv2.find contour functions. The argument cv2.chainApprox simple stores all the boundary points and are external external की करता approximate contour chain approximate man simple. Okay, then let me explain this edges underscore ri cv.canny blurred. Apply additional processing within the ROL. Further edge detection, line detection. Example, applying probability half transformation on edges within the RI. This function cv2.canny implements the canny edge detection algorithm, a popular technique for identifying edges. Here, these terms from y to y plus h, from x to x plus w, blurred. This refers to a specific region of the pre-blurred image. This is our region of interest. And what is this 52, 50 and 150? These are the threshold values, low and high threshold used by canny edge detectors. We have decided by hit and trial. Pixels with gradient magnitude exceeding the higher threshold are considered strong edges and marked as white, and pixels with less than 50 are marked as black. Then cv2.offline, it is probabilistic Hopf transform. Let me explain the parameters. The one is the parameter for the row accuracy, which controls the precision in detecting the distance from origin of the image to the line center. Lower value increases precision but might miss some line. np.pi by 180. This converts the angle theta from degree to radians. Threshold 60. This defines the minimum number of votes a line segment needs to receive to consider a valid line. Higher threshold leads to fewer but more robust lines. Minimum line length and maximum line gap. Minimum line length sets the minimum length for a line segment to be considered. Maximum line gap, it defines the maximum allowed gap between points on a detected line segment. This helps connect small edge segments into longer lines.